Good morning, everyone. Today I am going to present the topic Big Data, the evolution, definition, characteristics, and analytics. In today's digital world, enormous amount of data are generated every second from smartphones, social media, websites, online shopping, banking systems, healthcare devices, and IoT sensors. Traditional databases are no longer sufficient to store and process this massive amount of data efficiently. This led to the emergence of big data technologies. In this presentation, we will understand how big data evolved, what big data actually means, its important characteristic, the famous 4 V's, the challenges organizations faces, the requirements for implementing the big data solutions, how big data differs from traditional business intelligence, and finally, the different types of big data analytics. Let us begin by understanding the evolution of big data. During the 1970s to the 1990s, organizations mainly used relational databases to store structured data such as customer records and financial transactions. In the late 1990s, the rapid growth of the internet generated web pages, emails, search engine logs, and e-commerce data, increasing both the volume and diversity of informations. In the 2000s, companies like Google introduced technologies such as Google File System and MapReduce to process enormous data sets efficiently. These innovations later inspired Hadoop. During the 2010 cloud computing, NoSQL databases, and Apache Spark made storing and processing massive datasets much faster and more affordable. Today, in the 2020s, big data closely integrated with artificial intelligence, machine learning, IoT devices, and real time streaming systems, enabling organizations to make intelligent decisions instantly. So, what exactly is big data? Big data refers to the datasets that are so large, so fast, or so complex that a traditional software cannot efficiently store, manage, or analyze them. Big data is not just about the data itself, it also includes the technologies and tools used to process that data. Big data handles three different forms of data: structured data, such as databases, semi structured data like XML and JSON files, unstructured data, such as images, videos, audios, emails, and social media posts. Some common sources of big data include enterprise applications like ERP and CRM systems, websites and social media platform, IoT sensors, smart devices, surveillance cameras, medical imaging, and multimedia content. Big data has several important characteristics. The first characteristic is massive scale, meaning organizations generate data in terabytes, petabytes, or even exabytes. The second is high speed, where data is continuously generated and often needs to be processed in real time. The third characteristic is wide variety, since data exists in many formats including text, images, videos, documents, sensor readings, and database tables. Another characteristic is uncertain quality because collected data may contain errors, duplicates, or missing values. Next is high value. Individual records may not seem important, but analyzing millions of records together can provide valuable business insights. Finally, complex relationships exist because data comes from many interconnected systems requiring advanced technologies for integration and analysis. The most commonly used way to describe big data is through the 4 V's. The first V is volume, which refers to the huge amount of data generated every day. The second is velocity, which describes the speed at which data is generated and processed. Examples include stock market data and social media updates. The third V is variety, meaning data comes in multiple formats including structured, semi-structured, and unstructured data. The fourth V is veracity, which represents the quality and reliability of data. Since data may contain noise, inconsistencies, or errors, organization must validate and clean it before analysis. Nowadays, we also have the fifth V. Although big data offers many advantages, it also presents several challenges. The first challenge is storage and infrastructure because storing massive amount of data requires scalable and cost effective systems. Another challenge is data security and privacy since organization must protect sensitive information from unauthorized access. Maintaining data quality is difficult because data often contains inconsistencies, missing values, and duplicate records. Organizations also face integration complexity when combining data from different sources and formats. Another challenge is the skills gap. As experienced data engineer, data scientist, and analyst are in high demand. Finally, real time processing is challenging because organizations need to analyze streaming data almost instantly for timely decision making. To successfully implement big data solutions, organizations require several essential components. First, they need scalable storage, such as Hadoop distributed file system or cloud storage. Second, they need powerful processing frameworks like Hadoop and Apache Spark for distributed computing. Next is data integration, where ETL or ELT pipeline collect data from different sources. Organizations also require strong security and governance through authentication, encryption, access control, regularity compliance. Advanced analytics, machine learning tools help discover useful patterns and predict future outcome. Finally, a skilled workforce including data engineers, data scientists, and analysts is essential to design, develop, and maintain big data systems. So this slide compares traditional business intelligence with big data analytics. Traditional BA mainly works with structured data stored in relational databases. Big data can analyze structured, semi-structured, and unstructured data from multiple sources. Traditional BA usually process data in batches such as daily or weekly reports. Big data supports both batch processing and real-time streaming analytics. Traditional BA uses centralized data warehouse, whereas big data relies on distributed storage systems like Hadoop and NoSQL databases. Traditionally, BI mainly answers the question what happened. Big data goes further by answering what will happen and what should we do using predictive and prescriptive analytics. Finally, traditional BA scales up by upgrading hardware, while big data scales horizontally by adding more servers. Big data analytics is the process of analyzing large data sets to discover useful patterns and support better decision making. There are four major types of analytics. The first is a descriptive analytic, which explain what happened in the past using reports and dashboards. The second is the diagnostic analysis, which investigates why something happened by identifying root causes. The third is predictive analytics, which uses statistical models and machine learning to forecast further events. The fourth is prescriptive analytics, which recommends the best possible actions based on predictions. Organizations use all four types together to improve business performance and make data driven decisions. To summarize today's presentation, big data has evolved from traditional database to modern AI powered distributed systems. Big data is defined by the four V's: volume, velocity, variety, and veracity. Compared with the traditional business intelligence, big data supports multiple data types, real time processing, and predictive decision making. Successful big data implementation requires scalable infrastructure, efficient data integration, strong governance, advanced analytic tools, and skilled professionals. Thank you for your attention. I would be happy to answer any questions.